Hello all. In the last session we have seen what is sentence classification task and how RNN helps us to perform sentence classification task. We have seen the basics of RNN in the last session. So today in this session we would like to go deep into RNNs and see how RNNs will be able to handle variable length inputs. Okay, we will see simple RNNs. We will also see what are the non-linearity problems that we encounter when we deal with simple RNN architectures. Okay, now starting with how do RNNs. First of all, we'll see what are RNNs. As we have seen, RNNs are one type of neural networks which has internal memory, which can remember important things about what kind of input they receive and what is the previous word that has occurred in the state. Okay. Now when I talk about RNNs, firstly let's discuss about how do RNNs handle variable length inputs. Okay. Now when we talk about RNNs, when I process a sentence, okay, the first and foremost step that happens is if the sentence would be tokenized. Okay, when I say I am Asha, this given sentence which has 3 words would be tokenized into 3 different tokens. I am Asha has 3 tokens. Okay. After the tokenization is done, we will go for word embeddings. Okay. The word embedding or the vector representation of these 3 words would be given. Okay. And now we feed these tokens or vectors, word embeddings of the given words in the sentence as input to the RNN architecture. Okay. Now when I talk about a paragraph, I may have n number of sentences in the paragraph with varied lengths. Okay. Now when I talk about a paragraph, let's say I am Asha, I am working in KMIT. Okay. So I have 2 sentences here in which the first sentence has only 3 words, I am Asha. The second sentence has 5 words saying I am working in KMIT. Okay. So here I have only one sentence. Okay. I have 2 sentences with variable lengths. Okay. So how do my RNN architecture takes or process these sentences with variable lengths? Okay. So for this, to handle this particular variable length inputs, we have 2 approaches. Okay. When I talk about first approach, in the first approach we first convert the input to embeddings. Okay. Converting the input to embeddings is nothing but the vector representation of that particular words and averaging them. Okay. So when I talk about this, okay, when I talk about this, let's assume the sentence. Okay. So I have one sentence called John loves Mary. Okay. So what we do is we generate the vectors of each and every word. This is the first step. And in the second step, we try to average the vectors of the given sentence. Okay. So here, what am I doing? Vector of John plus loves plus Mary plus dot. When I talk about tokens, even dot is included as token. Okay. Now I average them. Okay. So I perform tokenization, I generate the vectors and I perform the average of the given vectors. Okay. Now when I do this particular thing, if I take another sentence, okay, so this is what I am doing. Okay, John loves Mary vector. So these are the word embeddings. I am averaging them and taking the result. This looks very simple, but what about the order? When I talk about order, if I take another sentence called Mary loves John. First sentence was John loves Mary. In the second sentence, let me take Mary loves John. Okay, so here what you have to understand is the words are same, but the order is different, which makes 2 different sentences. But when I am performing the average, as the words are same, my result would be same, which says that both the sentences are same. But in real, both the sentences are different. Okay. So this first approach fails miserably because though it is simple, it is not taking average. So it is not taking order into consideration. So if you have 2 different sentences with different meanings but same words, this approach fails. Okay. So that is the reason we go for second approach. Okay. Now the second approach, we start with RNN abstraction. Okay, so here what we try to do here is we read a word, okay, and then based on what has been read so far, we will figure out the mental state. Okay, when I talk about mental state, what is the current word, and then I attach this current word to the previous word. As I already told you, Asha is my first word. I read this. Next, I go for the next word, which is the mental state representation, which is am, and then I try to add this am to the previous word, which is I, and I make a sentence I am. Afterward, I move on to the next mental state, which is Asha, and I try to add this Asha to the previous two words, which are I and am. So this is all about your RNN abstraction. Okay, we read a word based on what has been read so far. We update the mental state and move on to the next word. Okay, so this is how your RNN will process the given word embeddings. Okay, so when I talk about this, let's see how does this work. Okay, let's take the same sentence, John loves Mary. Okay, so here for each and first I'll take my initial state and update this particular initial state with each and every word embedding. So first it will be John, next state it would be John loves, and the third state it would be John loves Mary. Okay, so when I take a simple pseudocode for this particular RNN, I take a initial word. For words in each and every word, I update that state with the state, current state, and the next word that is coming and go back to the state. Okay, so as you can see here, I take an initial state, I take a word, first word, see this V of John represents word vector representation. Okay, word vector representation of that particular word. So word embedding of this is updated. So first John will be read, next loves, which is updated with John, so I get John loves, and then Mary, John loves Mary, and then dot, which would be the final state. Okay, so here what we observe is the state that gets initialized first, and that would be passed through the different update layers during different iterations. Okay, so the network substructure corresponding to this step is called as cell. That is called as what? Each and every cells. Okay, so this stops when the input is exhausted. Okay, the cell state is stopped when I am done with the sequence. Okay, so this is simple RNN architecture. Okay, so when we talk about simple RNN architecture, okay, there is a problem of non-linearity. In the first, I have taken three words, John loves Mary, but in the second sentence, if I take John loves Mary but something has happened, okay, so I cannot use the same architecture because the second sentence has n different words compared to the first one. So this problem is called as non-linearity. So in order to overcome non-linearity, we would be using activation function. Okay, so here we say your updating the simple state with state and word by including your activation functions. So using the activation functions, it takes a single steps, transforms it in a non-linear fashion. Okay. Now RNN that recognizes grammatical English sentences. Okay. When I talk about RNN processing the sentence, not just updating the words, but also understanding the grammar in the sentence is also important. Not just reading the words and giving the words as sentences output. Okay, so RNN should also have the capability of predicting the grammar in the given sentences. So let's see how do RNNs have that capability. Okay, for which let us consider four words saying I, you, am, and are. Okay, so when I take these four words and try to join any of these two words to make a sentence. Okay, so when I join I am, you are, they are grammatically correct. I have four words, I am, you are. Now I will try to make a sentence with two words each. Okay, so out of these four words, I have two grammatical sentences, which is I am and you are. Okay, now when I talk about other combinations like I, are, and you am, they are incorrect. right? So how do RNNs know which sentences are grammatically correct, which sentences are grammatically not correct? So that is, in simple, we are giving RNN the capability to understand the grammar in the given sentence. Okay, so how do we build such kind of neural networks in RNN? Okay, so first what we do is we take the word embeddings. Okay, so I have 4 words: I, you, am, are. I have the corresponding word embeddings of these 4 words, and I try to build my RNN architecture. So I have taken an initial state, I have taken 2 update functions because I have only 2 words for each sentence. So I am giving I am and you are. Okay, so I am processing this through the state and I am adding that to the result. Okay, so when I talk about grammatical sentences, so my output here should be 1 if the sentence is grammatically correct. My output should be 0 if the sentence is grammatically incorrect. So how do we proceed? Did you all understand the first step? I have taken the words and the corresponding word embeddings. I have built the simple RNN architecture with respect to the word vectors with update functions. Okay, now let's consider with no activation function. If I am not using any activation functions, what I do is I take a simple function called return, where I update one state with the first word and then update that, okay, w1 into state plus the second word embedding with the word. Okay, so when I do this, the problem here which encounters is, look at this, when I do this particular thing. Okay, so here I have 2 words, word 1, word 2, along with the word embedding representations of these words which are represented as x1 and x2. When I go with this particular problem without activation functions, the problem is, as you can see, the desired result, the desired output would not match with the actual result that we get, because here RNNs are just using the update functions but not making any active state function there, because I am not using any activation functions. Even if you randomly change the weights in the W1 and W2 also, the output would not match with the desired result. Okay, so this says that RNNs will not work specifically without the activation functions. Now let's try to put activation function, and most probably for RNNs we will be using tan h activation function. Okay, hyperbolic tangent function, because that is the activation function. When the input is far from 0, tan h will try to squeeze it between minus to 1 to 1 and all that stuff. So we use r tan h as an activation function for RNN architecture. Okay, so when I use this particular activation function with RNN, okay, so my neural networks would be able to handle the grammatical sentences, understand what is there and produce the desired outcomes using the loss functions. Okay, so here we will be using magic constants. We update magic constants, and then when we talk about W1, W2 words along with bias in the simple update function, we use magic constant. We try to update the RNN with activation functions with which we would be able to identify the grammatically correct or incorrect sentences using RNNs. Okay, so just try to understand that RNNs will handle the sequential data and not just processing the data. When RNNs are used with activation functions, they can also identify the grammatically correct or incorrect sentences. Okay, thank you.